Hello, I bought this Schumacher 750 watt 12 volt inverter, and of course, everything I buy is broken. I kind of like broken things, it just gives me something to do. I got a whole stack of inverters on the shelf. I don't know why I bought another one, but here it is. And this is about as clean as I've ever seen. This thing looks like it just came out of the box. The person who sold it to me said it didn't work when he tried it at the beginning of the season, so he got rid of it and I got it. Okay, and I was at my kitchen table and I happened to have my voltmeter with me, and one of the things I do with these is this is the power switch over here, and I normally bring out a wire so I can remotely turn these things on. And besides checking to see if anything's shorted or something obvious, I was going through trying to find which one. One of these is connected to the positive terminal, and the other one goes to the electronics. And so anyways, I got the meter on ohms, if you can see it, and of course it's a low resistance here. Yeah, one of my leads is a little screwed up, but anyways, you can see it's a low resistance. And on the other side is the control electronics. You're seeing the capacitor charging. And to my amazement, because I was playing around, I flipped the switch and it's still open pretty much. And that's this problem. Now this, there's a little bit of corrosion in here, and I was thinking maybe this got some water or drink on it or something. But this board is about as clean as I've ever seen, and I don't know. Maybe someone spilled a drink on it in the factory or something. But anyways, there's corrosion on these switches, and a lot of these switches, if they're not used very often, will form corrosion on them. And I'm going to show you a little trick. As I can say, you don't see any continuity when you turn that thing on. So yeah, I'm going to turn this off a second, and I'm going to unsolder these wires and solder two more wires on. Okay, I'm back, and I've soldered two wires on here. These are the two original wires, and these two wires are connected up to a 75 watt lamp, and that's connected up to 120 volts. Now these switches can develop these oxide layers, and 12 volts isn't enough to break them down, and you've got an exceptionally low current here. And they use switches that really aren't rated for this low current, but they'll last 5 years or so. Maybe there won't be a problem. So this switch is hooked up. I got the lamp over here. You should be able to see it light up. And if we can burn away the oxide layer, we don't even need to replace this switch. Okay, turn it on. Ooh, there we go. Okay, I'm going to stop it again, and we're going to connect back up the wires. Okay, the old wires have been reconnected. This one shows low resistance, because that goes right to the power. And this other one over here, we flipped on, and then it goes down to low resistance. Now we'll plug the inverter in. And supposedly it's on. Let me just check this a second. 13.77. So yeah, it's fixed. So that's it. Cheap, quick fix. Didn't even have to replace the switch. Thanks for watching.